Okay, this is problem number 21 out of the book, section 2.6, so unrelated rates. And it's an inverted cone, so it's kind of like the conical tank we're filling or draining, except it's a sand pile that we're dumping sand onto at the rate, the volume is increasing at the rate of 10 cubic feet per minute. So they give us dV/dt, and they want to know how high the height of the pile is changing. That would be dH/dt. When the height is 15 feet high. So how fast is the height growing when h is 15 feet? So this is how it sets up. Okay, so they give us dV/dt, we want dH/dt, so that tells us we need a relationship between h and v. And for a cone, the relationship is the volume of a cone is 1/3 pi the base squared, so r squared times h. So 1/3 pi r squared h will give you the volume of a cone. And for us, they tell us that the relationship between radius and height is, so the diameter is about 3 times the height. So the diameter of the pile is about 3 times the height, which means the radius is about 1.5 times to 3/2 the height. So in our equation here, because we want dH/dt, that's going to tell us that we want to have h's in our equation because we want to figure out dH/dt. So that tells us we don't want two variables, we want to get down to one variable, so we need some kind of way to get rid of that r. And this little relationship right here is going to allow us to get rid of the r. So if r is 3/2 the height, 1.5 times the height, then I can just put that in there for r, and I get this for volume. So volume is 1/3 pi. Instead of r, I'm going to put 3/2 h squared times h. I'm going to simplify that a little, so square the 3/2 and square the h, and I end up with this. I end up with 9, I've got a 1/3 over here still, and then I'm going to have 9/4 pi, and then it's going to be, I square the 3/2, I got 9/4, I square the h, and this h is going to give me h cubed. Okay? So this is h squared times h would be h cubed. So volume is equal to that. So there I've got a relationship involving just volume and h. So you may want to pause the video here and see if you can solve the rest of it yourself. What I'm going to do is I'm going to differentiate both sides with respect to t, because I know what dV/dt is. So I'm going to differentiate this side with respect to t. It's going to give me dV/dt. On this side, well, let me cancel this a little bit. Let's make this a little simpler. The 3 goes into 9 to make that 3/4 pi h cubed. When I differentiate this side, this thing is just a number times h cubed. So I bring the 3 down in front, and I get 9/4 pi h squared, and then dH/dt. So that's the chain rule right there. I'm differentiating h with respect to t, so after I bring the 3 down and reduce the exponent by 1, then I have to differentiate the inside function, and the inside function is dH/dt. So that's the chain rule, okay? Now we know everything here, so we can put numbers in. This is 10, dH/dt is 10. H is, h is 15, so it's going to be 9/4 pi 15 squared times dH/dt. So we're going to solve that whole thing for dH/dt. So let's do that. I'm going to take 10 divided by 9 pi, multiplied by 4, divided by 15 squared. So 10 divided by 9, divided by pi, multiplied by 4, divided by 15 squared. So the height is increasing at 0.006 about. So dH/dt is 0.0063, and that's feet per minute. So let me multiply that by 12 just to get it in inches. So that's about 7.07. I'm sorry, I think I need to divide it by 12. Nah. So I'm going to multiply by 12, and that's 0.07 inches per minute. So this is about 0.07 inches per minute. Okay? So take a look at that, and if you that's a good review question, good test question. So you might try it in the book. It's part of the homework. And if you can't get it, then watch the video. Pause the video as you go through it, you know, so to make sure you're understanding it.